Morning, this is your stat sensei, Mr. Spensei, and this is regression equations, and we're looking at doing sentence stems on poverty and teenage pregnancy. So, the study was done to determine whether or not there exists a relationship between teenage pregnancy and living below the poverty line. So we know we see the word and they said relationship, and we see and so these are our two variables below the poverty line and teenage pregnancy. All right, the data for the percentage of the population below the poverty line in 12 states. So we have a sample size of 12, along with the number of teenage births per thousand for those 15 to 17 is found in the table, and the computer printout for the regression is provided below. It says write the regression equation and define y and x for this problem. Well, I'm going to start off by saying, let's go ahead and mark the important row. There's our y-intercept row. That tells us how to find our slope row. Our slope row is always going to be directly below it. And we also know that that means teenage births per 1,000 is our x variable. So we know this is our x. So at this point, I go, okay, this is my x, and this over here is my y. So teenage births is x, and the population living in poverty is my y, and below the poverty, there's y, and then teenage pregnancy over here is our x. Okay, so it says write the regression equation and define y and x in the context of the problem. Well, we know we're going to start off with y hat equals, well, there it is, our slope, our y-intercept, 1.1067 plus, because it's a positive, 0.4726. That's our x. That's our b. And then we're going to have an x there. Now, we can write it like that, but if we write it like that, we're going to have to define our variables specifically. So what I much prefer is if we write it like this. We know that poverty is our y variable, and teenage births, percent of teenage births is our x. So if we write it like this, we actually don't have to define our variables. So percent in poverty equals 1.1067, which came right from here, plus 0.4726, and then the percent of teenage births. Please remember, there's our y, this is our y, and this is our x. This is our slope. We also refer to as our b, and this is our y-intercept. And once again, this is the way I originally wrote it from the chart. Now, I have already entered this information into the calculator, in the stat edit, and I'm going to clear that out, but there it is. And if I go stat, test, letter F, alpha trace, there's my 1.106, and there's my B. All right, so that takes care of that. The next thing it asks for when I'm looking at the list is it says, um, write the slope and explain its meaning in context. I always like to take the slope and put it over 1. Okay, so in this case, oh, and by the way, I define my y and my x, just population and percent population in poverty, percent of teenage births per 1,000. All right, the number of teenage births per 1,000. Well, our slope we just identified is 0.4726. I always want to put that over 1. So 0.4726 over 1. Please remember, it's always the y's over the x's, just like we learned in algebra. And our y variable, oh, we said percent in poverty. Over our x variable, which is births. number of births. All right. So there's a 0.4726 increase. And the reason this word increase is because it's positive, this is going to be an increase. All right. If it had been negative, we would have said decrease. So there's a 0.4726 increase in the percent of poverty. And remember, this is my Y variable. For every 1 unit increase, and this will always be increase in the number of teenage births. All right, number of teenage births. And this right here is my X. And I'm just saying it really helps to make that fraction and go, oh, for every one, because that's where that one comes from. And it's positive. Okay, so that's where we get that positive from, or increase. All right, so we've taken care of the slope. Well, the next thing it asks for is write the coefficient of determination, explain its meaning and context. Well, the coefficient of determination, when I look at this table, I don't see it anywhere, but I know coefficient of determination is an R squared, and in this class, we'll never use the R squared adjusted, so our coefficient of determination, or this right here is our CD, is 57.33%. So 57.33% of the variation in percent living in poverty, which happens to be our Y, can be explained by changes in the number of teenage births. All right? And this is my X. All right? Please notice we're always going Y, then X, Y, then X, and we'll continue that. The next thing it asks for is the correlation coefficient. Okay, the correlation coefficient is nowhere on here, but it's going to be the sine of the slope. And since our slope is positive, we know our correlation coefficient is going to be positive, and then the square root of R squared. All right, so the square root of 0.5733, and let's do that in a calculator real quickly. 0.5733 raised to the half power is 75%. Now we need to remember, if it's greater than 0.75, it's strong. If it's between 0.4 and 0.75, it's moderate. If R is less than 0.4, it's weak. Well, in our case, we're greater than 0.75, not by a whole lot, so we're strong. There was a strong, and my slope was, what was my slope? Oh, positive. If it had been negative, we would have said negative. There's a strong positive linear relationship between the percent in poverty, which is my Y, and teen births by state, which is my X. Once again, continuing that YX pattern. All right. And this will always be an and there. Okay. This will always be an and. So there's a strong positive linear relationship between the percent in poverty, percent living in poverty, and teenage births. The next thing, the S, they're looking for the standard deviation of the residuals. Remember, we're just looking for an S by itself. It could show up anywhere, but we're looking for an S by itself. And the standard deviation of the residuals is 3.6588 and measures the variance in the percent in poverty for a given amount of teen births by state. So once again, this is my Y and this is my X. All right. Appreciate you watching. I hope that helped a whole lot. Look forward to seeing you on the next one. And this is the way the sentence stems are going to look from now on. All right. See you on the next one. Thank you.